Today we're going to look at section 10.3, which is all about the parabola. We're going to graph parabolas and write equations of parabolas in standard form. Now, the definition of a parabola is something that we've already studied before in several different forms. We looked at the fact that we have y equals a times the quantity x minus h squared plus k, which I call that vertex form, or y equals ax squared plus bx plus c, which we called standard form. The value of a always determined the direction of the parabola. When a was positive, the graph opened up. When a was negative, it opened down. And in that first one, like when I said vertex form, that's because the ordered pair hk was the vertex. However, today we're going to look at parabolas when they don't just open up or down, but now we're going to look at them when they potentially open left and right. So a parabola is the set of all points in a plane that are equidistant from a fixed line, which we call the directrix, and a fixed point, the focus, that is not on the line. The line passing through the focus and perpendicular to the directrix is the axis of symmetry. That's not anything new, axis of symmetry. We've been talking about that since the beginning of parabolas. Axis of symmetry helps create a symmetric or nice reflection. So the left side equals the right side, or in this case now, potentially the side that's above the axis of symmetry looks like the side below it. The point of intersection of the parabola with the axis of symmetry is called the vertex. So the vertex, if the graph opens up and down, is either the highest or the lowest point. And now if it's opening left or right, it's either the farthest point on the left or the farthest point on the right. The vertex is always midway, or the halfway point between the focus and the directrix. So these are the standard form equations now that we're dealing with parabolas that could open any of those four directions, up, down, left, or right. So when we have y minus k quantity squared equals 4p times the quantity x minus h, the y squared, or the y term, is squared. And so that's going to tell us that our graph opens left or right. The other standard form, x minus h quantity squared equals 4p times the quantity y minus k. Because the x term is being squared, that means the parabola opens up or down. And x squared, that's how we've always done parabolas in the past, and we've always had the parabolas open up or down. So it's just knowing that if it's a y squared term, that's when we're doing the whole opening left or right. HK is going to be the vertex, which, just like all the other conics, we're going to change the signs from both of those in order to create that vertex. And this term of 4p, that determines the direction the graph opens. Now, if that value in front is a negative, it's going to open either left or down. When that value is positive, it's going to open right or up. We also have something called the lattice rectum. This is a line segment that passes through its focus. It's parallel to the directrix, and it has endpoints on the parabola. So in the past, I've always had you graph 5 points in order to connect those points to form the parabola. In this case, now I'm only going to ask for 3. You're always going to have to obviously have the vertex in order to create your parabola. But now the other 2 points that are going to have to be on your parabola are these endpoints of the lattice rectum. The length of this lattice rectum is the absolute value of 4p. So obviously when we're talking length is always going to be a positive value, which is why we're taking the absolute value. But you could technically have a negative number that is that value of 4p. So let's look at a couple of examples. Here I'm giving us equations, and I'm just asking for us to identify the following: the vertex, the focus, the directrix, and the length of the lattice rectum. So the first thing we have to identify is the vertex. Now, in part A, notice that I don't see any numbers with the x or the y terms. There's nothing in parentheses, which tells us that we really then were subtracting 0. So our vertex is at 0, 0. The next thing that we're going to want to identify is the focus. But in order to do that, we need to know a couple of things. We need to know what direction is that graph going to be opening. And so in order to do that, we have to look at the value that's in front of the non-squared term. So in this case, 8 is that value in front of the non-squared term. 8 is representing that value of 4p. And so if I divide both sides by 4, we find out that the value of p is 2. And I need to know that information because that's going to tell me how far away the vertex is from the focus. So it's a distance of 2 away. So now I just need to know, is that distance of 2 going to be dealing with 2 to the left, 2 to the right, 2 up, or 2 down? So because my value in front is a positive number, that indicates that it's either going to be opening up or to the right. And so because my y term is what's being squared, that means that we are going to be opening to the right. Okay, so it's a positive p-value and it's a y squared term. That's why it's opening to the right. So think about going from your vertex and moving 2 to the right. That's going to change the x value. So that's why my focus point is at 2, 0. My directrix, that is going to be a line. It's either going to be a horizontal line or it's going to be a vertical line. Because I know my graph opens to the right, so I know that it's going to look something like this, where my focus is always inside of that parabola. That means that my directrix has to be a line that will not intersect that parabola. So that means to draw a line that's not going to intersect, it has to be a vertical line. And so that means it has to be x equals in order to create that line. So now I just need to know, well, what is that value? So from my vertex, if I went 2 to the right to identify the focus point, from the vertex, I go 2 to the left to get the directrix line. So from 0, 0, going 2 to the left makes that hit at -2. So x equals -2 would be that directrix. Last thing we want is the length of the lattice rectum. So I just abbreviate that as LR. All right, so then remember, that is always going to be the absolute value of the number that's in front of the non-squared term. Notice that it was 8 that was in front of the non-squared term. Well, the absolute value of 8 will stay 8. So 8's that length of the lattice rectum. If we move on to part B, I want the vertex. And notice that this time we have a number that's in parentheses with the x. So that represents the h value of my vertex. I change the sign, it turns to +1. Since there's nothing in parentheses with that y value, it's going to stay 0. So there's my vertex. So to identify the focus point, I once again need to know what is my p-value and what direction does my parabola open. So we look at the number that's in front of the non-squared term. -20 is going to equal 4p. So if I divide both sides by 4, we get a value of -5. So notice that my graph or my p-value is negative. So that means I'm either opening to the left or I'm opening down. Because my y term is not squared, it's my x term that is squared. That means we're moving up and down. And since p is negative, that means that my graph is going to open down. Okay, so if my graph opens down, that means that my focus point has to be inside of that parabola. So from the vertex, if I have to move down and I'm moving down 5, I'm not going to change the x value. It's the y value that changes. 0 minus 5 gives me -5. So 1, -5 is the focus point. And so because my directrix has to be a line that doesn't intersect that parabola, this time it's going to have to be a horizontal line. So to identify the directrix, I know that it's going to have to be the line y equals. So now, once again, from that vertex point, I have to move 5 away from that. So I have to move 5 up. So once again, it's the y value from the vertex that I want to move 5 up from. So 0 plus 5 tells us that y equals 5 is that directrix. And then the length of the lattice rectum is going to be, once again, the absolute value of that p, or the 4p value. So the absolute value of negative 20 gives us a length of 20. Let's take that information now and let's go ahead and start graphing. So if I want to graph y squared equals negative 12x, because there are no numbers in parentheses with the x or the y, that tells us that 0, 0 is that vertex. I need to figure out what my focus and directrix are. So I look at the number that's in front of the non-squared term. Negative 12 is going to equal 4p. Divide both sides by 4, we get negative 3. Because my p-value is negative, that means we're either moving to the left or we're moving down. Since it's a y squared term, that means my graph opens to the left. So that means that my focus point is going to have to be to the left of my vertex. And so that means if I'm moving right or left, I'm focusing on the first number in my vertex. So I'm going to move 3 to the left of 0, which would give us negative 3, 0. Okay, so I know that my directrix then is going to have to be, so here's a quick little sketch, is going to have to be a vertical line, so it does not intersect that parabola. So that means it's going to have to be x equals a number. So from the vertex of 0, 0, I need to move to the right to create that directrix. And we're moving the distance of p. So 3 then to the right would be x equals 3. Length of the lattice rectum is the absolute value of whatever number was in front of the non-squared term. So absolute value of 12 would be 12. So let's plot our vertex, that's at 0, 0. Plot our focus point, which is at negative 3, 0. I can draw my line for my directrix. That would be this vertical line. And so, like I said, I need to have 3 points to form my parabola. My focus point is not going to be connected to anything in my parabola. So remember, the length of the lattice rectum is going to help me get that. So it's going to be my endpoints of the lattice rectum is lined up with the focus point. So I want to cut that lattice rectum in half. So from negative 3, 0, I'm going to go up 6 and plot my point. And from that focus point, I'm going to go down 6 and plot my points. So notice that together, that is a length of 12, but I cut it in half from the focus point and line that up. So if I now connect the endpoints of the lattice rectum to that vertex points, there is my full parabola. Okay, if we graph another one, notice that this one, we have to do a little bit of work first because my squared term is not completely isolated by itself, so I don't quite have it into standard form. So I'm going to take that 2, I'm going to divide both sides by 2 to get that squared term alone. 16 divided by 2 is 8. So now, once I've divided by 2, I have my standard form. So now I can identify my vertex. Remember, the h goes with the x, the k goes with the y. I changed the signs. So 3, negative 1 is going to be that vertex. I know to find my focus point, I have to look at the number that is in front of the non-squared term. So 8 equals 4p. Divide both sides by 4. I get p to be 2. It's positive, which means it either opens to the right or it opens up. Because x is what's being squared, that tells me my parabola opens up. And so, quick little sketch. If it opens up, my focus point is going to be somewhere inside of that parabola. So from my vertex, that means that it's not going to be the 3 that changes. It is going to be the y value. And so remember, the distance from P, or the distance away from the focus point to the vertex, is that length of P. So from negative 1, I'm going to add 2 onto it. Negative 1 plus 2 gives me positive 1. I have to go in the opposite direction to get my directrix. It's going to have to be a horizontal line, which means that it's y equals. So from the vertex, I'm looking at -1, which is the y value, and I want to go down 2. So -1 minus 2 tells us that y equals -3 for our directrix. And then length of the lattice rectum is whatever that value was in front of the non-squared term. The absolute value of 8 is 8. So now if I start plotting my points, 3, -1 is my vertex. 3, +1 is my focus. Y equals -3 is that horizontal line, which is my directrix. And because I know the length of my lattice rectum is 8, from the focus point, I'm going to cut it in half, and I'm going to go 4 to the right, 1, 2, 3, 4, plot my point, and from the focus point, go 1, 2, 3, 4 to the left, and those then are the points that get connected to the vertex to create the shape of our parabola. And there's our graph. All right, looking at a couple of having to write equations. So we want to find the standard form of the equation of the parabola. The focus is at 8, 0. The directrix is x equals -8. So the moment I see that it says x equals -8 for the directrix, remember, that is a vertical line. And so because that's a negative value and the focus point is at 8, 0, meaning it has to be to the right of that, if my focus point is to the right, hopefully we're okay with the fact that our graph is going to have to look something like this. And so that means if we're opening to the right, that means that our squared term is going to have to be the y. All right. Remember, your focus point is lined up with your vertex, okay? So because I am then lined up to that focus point, the y value of my vertex is not going to change from the y value of my focus. So I know that that's going to be 0 for the second half of my vertex, okay? Notice that this distance has to be the same as this. Okay, so hopefully we understand that. How did I go from then +8 for the focus to -8 for my directrix? Well, that's really then halfway between those 2 points would have to be 0. So vertex is 0, 0. So the y² term allows us to know that our graph is going to be opening to the right. Okay, we know that our value to go from 0, 0 to 8, 0, that is a length of 8. So that is our p value. Okay, so if our p value is 8 and it's positive because we open to the right, then I know that the number that's going to be in front of my non-squared term is always 4 times p. Well, 4 times 8 is 32. So here's my equation. All right, lastly, the standard form equation of the parabola is what we want. Our focus is -3, 4. The directrix is y equals 2. So if it's y equals, I know that we're dealing with a horizontal line. If I know that that is 2 and -3, 4, if I'm thinking about trying to like plot that point, -3, 4, well, 4 is up here. So that means that if my focus is above the directrix, that means that my parabola is going to have to open up, which means that I know that my squared term is going to be the x value. Remember, your focus is always going to be lined up to your vertex. That means in this case that my vertex, the x value is not going to change. That has to stay -3. So if I know that 4 is where my focus point is and 2 is where my directrix is, I need to know what's halfway between that, and that's going to be 3. So my vertex is at 3, 3. So what's the distance between my vertex and either one of those? Well, I had to go up and down 1. So that means that my p value is 1, and it'll be positive because my graph is opening up. Okay, so if I start plugging that information in, the x term is being squared. I always change the sign of my vertex to get back to my standard form. So x plus 3 quantity squared. That equals, remember the number that's going to be in front of my non-squared term is always p times 4, or 4p. So since p is 1, 4 is going to be that number. And then we'll have y minus 3 to finish out the rest of that equation. Okay, so that's us graphing parabolas and writing equations in standard form.